So page 24 in your notes, we left off right here, at which point I did the card thing with you guys, which y'all got mad at me for. But I feel like I was able to show you that if something doesn't happen very often by chance, we start to become suspicious that there's another explanation other than chance for why that thing is occurring. Do you think that the difference between mean pulse rate we found from our experiment is due to the caffeine, or has it occurred purely by chance? Remember, when we assumed it occurred purely by chance, and then we did our simulation, we got the experiment results or more extreme in 27% of those simulations. Do you think that that 1.2 difference that was seen in the experiment was due to the caffeine or due to chance? Probably due to chance. Why? Why would we think that this is probably due to chance? How often did it happen just due to chance? 27% of the time it happened just due to chance. It occurred in 27% of the simulations which is not rare. So our general rule is that if our number of times, our percent of times this happens in a simulation, in the simulated results, if it happens less than or equal to 5% of the time, it's pretty unlikely to happen just by chance. Y'all were super suspicious. I did the same card thing with fifth period today, and they let me get all the way up to 6 cards before somebody called me out. Yes. So I had a deck of cards, and I said the first person to pull a black card gets 10 extra credit points on their next test, but it was a deck of all red cards. Yes.
Can you actually do it with like black cards?
No, seriously, I was like, if you like want to open this thing up, like,
I'll see what I can do. I'll see what I can do.
I'll take 5 points. I'm like,
if something happens more than 5% of the time just by chance, it's not rare. So what we saw as the results of the experiment would likely just be a coincidence.
oh my God.
Do you like it?
Tight?
Oh, get it.
Oh.
Hey, let's wrap that up.
Just wait until Pi Day, then we pull out all the puns. But sometimes we bring snacks too.
Okay, I'll take it. A circular snack. I like cookies.
All right. When you are done getting this copied into your notes, we're going to go on to the next question. Very bottom of the page, question 7. Mrs. Bolliton, right next door, did the same experiment, but with all of her students. She's got 136 students. They were randomly assigned either caffeine or no caffeine. The mean change in pulse rate for the caffeine group was 2.8. And for the no caffeine group, it says for the caffeine group twice. This should be no caffeine group, was 1.9. Is that evidence more or less convincing than the original experiment? What's the difference there? 0.9. What was the difference in the original experiment? 1.2. Are you guys more or less convinced? Why? The difference is smaller, but she's got something going for her on this one that I didn't have in mind. How many people did I talk to? How many people did I have participate? I only had 20. 10 in the caffeine group, 10 in the no caffeine group. She had how many people participate? 136. So honestly, I'm going to go with a little bit of both. The results, the difference in means, less impressive, but she had a larger sample size, which offers a little bit more weight to it. All right, so big takeaways from yesterday's lesson and the wrap-up of it today. Something is statistically significant when the results of an experiment are unlikely, less than 5%, to happen purely by chance. If something is statistically significant, then we say we have convincing evidence that the treatment caused the difference. You guys, when you spoke up and called me out yesterday, you felt you had convincing evidence that I was not being honest. And that's why, and honestly, in fifth period today, when it took them till 6 cards, that person was pretty sure I was lying at 3 cards. They didn't speak up until we had a little bit more evidence. They felt they had enough evidence to call me out as lying. So if it's statistically significant, we say that the treatment is the thing that caused the difference. I would like for you guys to try the check your understanding that's down at the bottom. We're only going to take about 4 minutes for that so that we have enough time for everything we need to get to today. So check your understanding down at the bottom. Take about 4 minutes to do that. The difference between these is 4%. All right, then number 2, 2 parts to this question here. In your own words, what does statistically significant mean in this context? What does statistically significant mean? Yes. It means that we would be able to show cause. How likely would it be to happen just by chance? Very unlikely to happen just by chance. Do you guys feel like this difference in percents, 4%, is statistically significant? No, doesn't seem very big. So it means the difference of percents from the experiment would be unlikely to happen purely by chance so that we can determine cause. In this instance, because the difference is so small, and this is just a gut answer, this is not, you're never going to be asked a question like, do you feel if it is statistically significant? Because we're going to learn ways of testing whether or not it is statistically significant. And actually, the last question on the page does just that. Do you guys remember how we made our dot plot yesterday? I gave you those cards. We assumed that it was just due to chance. So we took all the results from the experiment, we mixed them up, and we assigned them to two different piles. So they did that exact same thing with this situation, looking on whether or not the ad gets clicked on or not. And they did that simulation 100 times over. And that's what this dot plot is here. What percent of these dots came in at 4% or more extreme? 4% or more extreme. There are 42 dots. Yep. At the 4% mark, there's 42 dots, and there's 100 total trials, so 42%. So do you think these results are statistically significant? No. 42% of the time, we would get this difference in percents or more purely by chance. The event is not rare. We expect it to happen pretty often just due to random chance. When you're done getting that into your notes, you're going to flip the paper over. There's nothing on the back side of this page, but we're going to go to page 27. And if you look at page 27, there are 6 descriptions of studies. 6 descriptions of studies. And those sentences that I had you guys cut out at the beginning of class, those are conclusions that could be reached from these 6 studies. The wording is very similar, but the differences are very important. I'm going to give you guys about 5 minutes. Feel free to work with partners. Small groups is fine. I want you to try to match the conclusion to the study that it goes with. Take about 5 minutes to try to match the conclusion to the study.
If they randomly assign them, can you say costs?
Ooh, good question. All right. I know you might not be all the way done. That's okay. Is there one that you are reasonably confident that you have placed correctly? Does anybody have one that they feel reasonably confident? No? You have one that you think? C for one, yes. Once we've verified that that's what it is, please feel free to tape or glue it in place. Did this study use a random sample? No. And so when they reached their conclusion, they could only talk about students in that class. Did they use random assignment? Also no. And so they could only conclude that there was an association or a relationship there. Couldn't talk about cause and effect, and we could only generalize to the people that were in that class. Does anybody else have one? Or same person, Faith, you're welcome to go again. Does anybody else want to try their hand at guessing which ones would match? Sure. E for 2? Yes. E for 2. Did this study use a random sample? Yes, this study used a random sample. And so when they reached their conclusion, they didn't just talk about the seniors in their sample. They talked about all the seniors at the school. When you take a random sample, you are allowed to generalize your findings to the larger group, the population that you took your sample from. Did they use random assignment? No. No random assignment. So again, they could only assume that there was an association. Or sorry, they could only conclude that there was an association. All right, we got 4 more to go. We're getting now into better percentages. You have an idea, Annie? A for 3, yes. Did they use a random sample here? Yes, they did have a random sample. It says select a random sample of students who have taken the SAT from your school. And so we can generalize the results to all students who have taken the SAT at the school. Did they use random assignment? No. Again, no to the random assignment. So we could only conclude that there was a relationship, an association between these 2 events. All right, we're down to the last 3. 33% chance of getting it right. Abby.
It's 4D.
4 is D.
Yes.
Oh, I missed them.
Was there a random sample taken? No, there was not a random sample. It says get all of the students in a senior-only class to participate. And so you can only make your generalizations to students that are in that particular class. Was random assignment used? Yes. And so what can you say because of the random assignment? Yes, we can determine cause here. All right, we got a 50-50 shot, Deborah. F for number 5, yes. Was a random sample taken here? Yes. It says select a random sample of seniors from your school. And so we can generalize to all the seniors at your school. Was there random assignment? Yes. And so that lets us say what? Causes. All right, so the last one, everybody together. What's the last one? B. I heard almost everybody say B. Did they use a random sample here? Yes. They had a random sample. It says a random sample of students who have taken the SAT from your school. So we can generalize to all of the students who have taken the SAT at your school. Was random assignment used? Yes. And so we can talk about cause. It says randomly assign. This one says randomly assign. This one also says randomly assign. All right. So our big takeaways, why I had you guys work on this. If you flip the page over, a random sample allows us to generalize our conclusions to the population from which we sampled. So if I do a random sample from this class, if I pick out, say, 5 of you, I can only take those results and generalize to this class. If I take a random sample from the whole school, then I can generalize my results to the whole school. But if not everybody in the whole school has a chance of being included in the sample, then I can't generalize to the whole school. Random assignment allows us to conclude that a treatment causes the changes in the response variable. I would like for you guys to take let's do about 3.5 minutes for the check your understanding at the bottom. Observational study or experiment? Experiment. Oops. Hold on. This is messing up on me now. There we go. Why did we conclude that this was an experiment? What was it that you saw that made you say experiment? He's comparing two things. He's assigning the treatments. Comparing two things and assigning the treatments. What was the explanatory variable? Screen brightness. Response? Battery life. Was a random sample taken? Yes, a random sample was taken. Was random assignment used? Yes. So random sample and random assignment, which means we can conclude what? Screen brightness does affect battery life. Specifically what? Causes. I heard new iPhones. What'd you say? I still couldn't hear you. Okay, sorry. What kind of, yeah.
Lower battery causes better battery life. Or lower brightness causes longer battery life.
Lower brightness causes longer battery life. I love it. Who could we make this generalization about? New iPhones. All new iPhones across the world? In that store. All brand new iPhones from that store. Low screen brightness causes increased battery life. The population that we take a random sample from is the only population that we are allowed to generalize our results to. When we randomly assign treatments, that's what allows us to determine cause and effect. I did not think we were going to get through everything today. All right, so that finishes up chapter 4. We are all done with chapter 4. Monday, what do you need to have for me? Homework. I need homework from you on Monday. You'll get the test review on Monday. We're going to do our own version of the caffeine experiment on Monday. You are going to drink a carbonated beverage that is either caffeinated or not caffeinated. 5th period has requested that I try to find Dr. Pepper. Yes. Okay, so here's the thing. I have to be able to find a caffeinated version and an uncaffeinated version. If I can't, then I'm going to have to go with Coke. But my goal, I'm going to Kroger right after school. My goal is to find Dr. Pepper. Yes, sir. We graded it yesterday. Yes, homework 3 is in that blue organizer there at the very bottom. Tuesday, we're going to practice free response questions. Wednesday, I'll take questions that you guys have over the test review, but the test is not till Friday. Normally, I do that the day right before the test, but I don't see you on Thursday. That's the day we're going to do multiple choice practice. It is really important for your attendance that you get into Canvas. That's the only way to access the Google form for the multiple choice practice. So make sure you get into Canvas because that's how they're taking attendance that day. They're monitoring activity in Canvas. There are no Zooms. We're actually moving over to Microsoft Teams, but there's no online video meetings for any of your classes. But you will have assignments in each of your classes. Like I said, ours will be multiple choice practice. So make sure you get in, look at the module. There is stuff in My AP as well, but if you don't get into Canvas, you get counted as absent. So make sure you get into Canvas, do the Google form one at least, then hop over to My AP. So that's Thursday next week. Friday is your test, and I'm not assigning you guys anything over break.